For many years, concrete paved the way for changing the world. From creating roads and bridges to transport food, to connecting cities, from the smallest of construction to the highest of buildings, concrete solidifies itself to be one of the fundamentals in the industry. But there's a problem. Conventional concrete has low tensile strength compared to its compressive strength, making it vulnerable to lateral forces that can lead to cracking. And these cracks impede the integrity of a member, in the long run requiring high repair and maintenance. To address the problem of conventional concrete, different mix designs were developed, and one of them is bendable concrete. Developed by Professor Victor Lee of Michigan University, Engineered Cementitious Composite, or ECC, also known as bendable concrete, seeks to address the brittleness of the ordinary concrete by making it flexible with an increased tensile strength, high ductility, and tight cracks within control. ECC is made up of all ingredients of traditional concrete, but instead of coarse aggregates, fine aggregates will be utilized with the incorporation of fibers as reinforcement and admixture. Fibers stiffen and strengthen the composite, giving it the ability to carry heavier loads. It does not only hold the mix together to restrict expansion of cracks, but also reduce and sometimes eliminates the use of steel reinforcements. And with these innovations, bendable concrete presents more advantages than conventional concrete. The flexibility and ability of ECC to take tensile stress up to 10 to 15 MPa makes a structure more resistant and less prone to damages under vibrations that can only be induced by seismic activities. The self-healing property of concrete extends its service life as the cement particles make reactions with the rainwater and carbon dioxide that expands and fill the microcracks that are developed in the flexible concrete. These properties reduce the cost of repair and maintenance. Bendable concrete limits the use of cement to protect the environment by emitting low harmful gases. Studies found that the carbon emission from cement is almost 80%, which is equivalent to 8% of the carbon dioxide emission of the world. It also consumes 36% less energy than conventional concrete. However, bendable concrete's widespread adoption is hindered by several factors. As of 2019, it is recorded to be 4 times more expensive than traditional concrete. Its compressive strength can be smaller than traditional concrete, and the quality of concrete depends on the materials used and certain conditions under which it is made. Here is where the students take part in this innovation, a competition that aims one thing: to produce bendable concrete with an innovative mix design. Teams of students are challenged to produce concrete samples that apply sustainability concepts and use their knowledge of concrete mixture design. They are to produce and design innovative bendable concrete that has to have improved compressive strength without compromising its bendable capacity. Additionally, teams should develop a mix design that has the lowest amount of cementitious materials but shall maintain the mix overall performance. Mixture shall be proportioned to result in bendable concrete, where materials like fine aggregates, cementitious materials as binder, chemical admixtures, fibers such as glass, natural, and synthetic shall all conform to ASTM standards. Teams shall provide 3 specimens: 2 cylindrical specimens, 1 that shall undergo ASTM C39 or standard test method for compressive strength, and 1 that shall undergo ASTM C496 or standard test method for splitting tensile strength of cylindrical concrete specimen, and 1 beam specimen for the flexural strength test that will undergo ASTM C1609 test. The dimensions of the specimen shall all conform to ASTM standards as well. Additionally, the bending strength of concrete specimen should be 10 megapascals or greater. Entries will be evaluated under 2 categories: Most Innovative Design, where a report which contains the documentation of the project, and Outstanding Performance in terms of compressive, tensile, and flexural strength. With this competition, the American Concrete Institute will be able to host an event that gives room for improvement of ECC and bendable concrete, which are continually evolving over time. This will give the spotlight to the innovation, advancement, and the development of the concrete industry. The research conducted by the students can become a reference standard that consider cost and availability without compromising its performance. This will lead to the global recognition of ECC and gives it the opportunity to replace conventional concrete, most especially for countries that are more vulnerable to natural disasters. And who knows, Bendable concrete might be the future of concrete industry. Never broken, just bent.